Hi everybody, Patrick here from EngineeringShock.com, PaintballProps.com, and EscapeRoomElectronics.com. This is project number 5 for the Arduino Playbot. The previous project videos can be found below, along with the Kickstarter campaign. So what we're going to do now is, I've written a piece of software, and what it does is it allows for you to use the analog, any of the analog pins, unused analog pins from your Atmega 328PU chip to reset, to essentially software reset your device. So what happens is the reset line is tied to a reset button, but it's also tied through it's tied to 5 volts through a protective 10k ohm resistor. And I'm going to show you the schematic, and I'm also going to show you the basic piece of code that you need to do this. You just need to call a subroutine that I've written and make a connection from the A0 line to the reset line. Now, as soon as you call this subroutine in software, it's going to create a software reset. What it's going to do is it's going to change the analog, the A0 line, which is a high impedance input. It's supposed to be used for sampling analog signals, and we're going to turn it into a digital output mid-code once we call this function. And as soon as it does that, it's going to pull the reset line low. It's going to act as a short to ground through that 10k ohm resistor. So it's essentially going to be pressing the reset button, but we're going to be doing it through software. And it's extremely easy. So now what I'm going to do is I'm going to show you the schematic and the function, and then we're going to give this a demo. After you've connected the A0 pin from the Atmega 328PU to the reset line, you can call this function at any time, void software reset. And most of this function that I've written here isn't necessary. I've added some LCD commands in here just to tell you that the software is about to be reset. So we clear the LCD, wait 10 milliseconds, print the first line of the LCD software reset, set the cursor to the bottom left area of the LCD, and then print in 5 seconds. Then we have a delay of 5,000 milliseconds, which equates to 5 seconds. And at this point, we change the A0 line to an output. And actually, that's all you need. The next 2 lines aren't even necessary. As soon as you change that to an output, what it does is it pulls the line low instantaneously, which is enough to reset the system, or reset the chip rather. But just to be thorough, we'll digital write A0 low, and we'll wait 10 seconds. But at that point, we've performed a reset. So this is an easy way to perform a software reset. In this schematic, you'll see that we've got the 2 ground pins of the Atmega 328PU chip grounded, or connected to the ground line rather. We've got our 2 VCC lines connected to the 5 volt line labeled VCC, and the X1, X2 pins are connected to a crystal oscillator, a 16 megahertz crystal oscillator with 2 18 picofarad capacitors tied to each side and ground. Now on the left, we've got the reset button schematic. So when we press reset, what happens is it connects the reset line to ground. But we've got a 10k pull-up resistor between the reset line and VCC, 5 volts. So it's protected. If we didn't have that protective resistor there and we pressed reset, the reset button, it would short VCC directly to ground, which would ruin your power supply. And it's just not good. So you need to have a protective resistor there, in this case 10 kiloohms, to limit current. In any case, when the button isn't pressed, the reset line sees 5 volts. So when we connect the A0 line to the reset pin, then we can we can declare the A0 line as an output later on in the software. It doesn't have to be done during void setup. We can change it from an analog input to a digital output, and the second we do that, it's going to cause a reset. So again, it doesn't matter what program you place this subroutine in. Whenever you want to reset, you just have to call the subroutine that we've just talked about, or call the function rather. So I'm going to plug it in, and as soon as I clap once, I'm just using the basic, one of our previous pieces of code. Just clap once, and what it's going to do is it's going to turn the relay on. The LCD will say relay turned on, and then what it'll say is software resetting in 5 seconds. After that, it'll be the exact same as pressing the reset button. So I'm actually going to power it up and show you what happens when you press the reset button right off the bat. It just resets the system. So, cloud detected, relay on, software reset in 5 seconds. Now if I remove that A0 to reset line connection, cloud detected, relay on, software reset in 5 seconds, but it's actually not going to reset. It's going to wait for another clap. Relay off. And I haven't written anything into the software to say waiting for clap again, but nothing happens. No reset. I can manually reset, and it resets to wait for clap, but it'll only software reset if I've got the A0 line connected to the reset line. Now you can't use digital pins to do this, at least not in my experience. I've given it a try. I've even tried to manipulate the software so you can use digital pins, but the nice thing about the analog pins is they're not doing anything. They're not offering voltage, they're not pulling, they're not acting as an open source to ground. They're simply just looking at what they are connected to. And so as soon as we decide to change or rather declare the analog pin as an output, as a digital output, we don't even have to set the line low. Instantaneously, it will sync 5 volts to ground through that protective 10 k ohm resistor and act as a reset, an instantaneous reset. And it's a very safe way to do it. So thank you for watching. I sincerely appreciate your patience and time. I hope that even if you haven't pledged towards the Arduino Playbot, that this video has helped you. Next, we're going to be doing a very fun software freeze program. And again, you should be able to do this even if you don't have a Playbot. And what I mean by software freeze is, well, I'll wait for you to watch the next video. Thanks for watching, everyone.